Hello, this is a geometry video, chapter 4, section 8. It is the last section of the chapter, thank goodness, but that also means that there's a test coming up, so make sure you start reviewing all of the sections and whatnots. But anywho, today we're going to be working with triangles and coordinate proof. And believe it or not, if you're a big fan of algebra, coordinate proofs can actually be a lot easier for a lot of people than the normal proofs. But before we get into an actual coordinate proof, we're going to talk about how to position diagrams so that you can make them convenient for a coordinate proof. So that might not make any sense right now, but you'll see as we go along why this is really important. So the first example here says, position and label right triangle MNP on the coordinate plane so that leg MN is A units long and leg NP is B units long. And again, you're looking at that, you're probably, what? Basically, we have a right triangle, and a right triangle is going to look something like this. And the triangle's name is MNP, so they want the legs to be MN and NP. So the only way for that to happen is for this to be N, and you can put like M over here and P over there, and now you have a leg NM or MN, which is that leg, and you have NP, which is this leg. That's one option. But you could also put, you can also make this M and then have leg MN and NP. And that's actually what I'm going to go with, but again, either way would have been fine. So I want to show you how this triangle could be this direction, it could be looking like this, with a 90-degree angle. So you can rotate the triangle in a lot of different ways, but they want us to position it in such a way that the leg will be A units long. So basically what we want to do is put our right triangle right here, and it's convenient for us to position the right angle at the origin. So I'm going to call this N, and currently this is the actual origin right here. Okay, but I'm going to call that N. And then this is my leg, so this is going to be my M up here. And then down here we're going to get P. Now it's convenient for me to position the vertex, the right angle over here at the origin, because now when it says that MN is A units long, it means that this distance here is A. So if I wanted, the coordinates of N currently are 0, 0. Remember, we are doing coordinate proof, so we want the coordinates of N would be 0, 0. And since this has to be A, the X coordinate is definitely going to be 0, because you're on the y-axis, so the x-coordinate of this point is 0. But the y-coordinate is going to be A, because they told us they wanted it to be A units long. And then P will be very similar. In the P case, we know that the y-coordinate is 0, because it's right on the x-axis. And they want the leg to be B units long, so that means that this is going to be B. So from here to here is B, and then that would make it B units long. And so basically, that's how you position this triangle so that it's in a convenient way. Again, they're not asking us to prove anything right now, they just want us to position the triangle. So now I want you to try to position and label an isosceles triangle on the coordinate plane, and it gives you some conditions that they want you to uphold in that. So you'll do that. I'll help you with that if you don't figure it out in class. But now we have example 2, and again, we're still not quite at the point where we're doing a coordinate proof just yet, but we're almost there. In this case, example, they've already positioned the triangle for us, and it says, name the missing coordinates of isosceles triangle XYZ. This one's going to be really easy. We just talked about that in the previous example. Let me get my eraser in so I can erase some of these question marks. We have question marks here because we don't know what it is, but we do know what it is. At the origin, you're going to be 0, 0. So for the coordinates of x, we know that x is 0, 0. And then we're going to go to over here to Z is probably the next easiest one. And again, I need my eraser because the y coordinate is not given for this one. The x coordinate was given as A. So the y coordinate has to be 0 because it's on the x-axis. So that'll take care of that guy. And then our last one is going to be y. And we need to figure out what those coordinates are going to be. Okay, now what they told us in the problem is that it's an isosceles triangle. So if it's an isosceles triangle, that means that these two legs are the same, and this leg here is A, so this point has to be in the middle. So if this whole segment is A, then the middle, which is the x coordinate of y, is going to be A divided by 2. I hope that makes sense. That's not a 9, okay? It's an A. Maybe I can write that a little bit better. It looks like a little 9, but A divided by 2. Okay? And then for the y coordinate, since we don't really have any other indications how tall this is, we can just call that B. So there you go. We have given the missing coordinates of the isosceles triangle for this little guy. So now you are going to try to name the missing coordinates of this isosceles right triangle, and hopefully you'll have some luck with that. If not, I'll help you in class. And now finally we're going to get to example 3, where we're actually going to write a coordinate proof to show that a line segment joining the midpoints of two sides of a triangle is parallel to the third side. This is actually a theorem we already had earlier in the year. It's the mid-segment theorem. And so basically we have a triangle. Each side of the triangle has a midpoint. So we're claiming that T is in the middle of C and B, and S is in the middle of A and C. And when you connect that, you get a line segment. And we want to prove that this line segment is parallel to the third side. Okay, so there's a couple of things that we have to do. The first thing we have to do is the problem actually is only the gray part up here. I put all of this black stuff here in the diagram based on what I know. So I'm given a triangle, and I'm just going to go ahead and call it ABC. You can call it whatever you want, but in my case I call it ABC. And then I'm calling the midpoints of the sides S and T. So S is the midpoint of AC. I'm right here. And T is the midpoint of BC. And all this information is given. And they want me to prove that the segment that I got here, ST, is parallel to AB. All right? So the first thing we have to do is basically position our triangle on the coordinate plane in such a way that will make it convenient. So I put point A over here at the origin. And the other thing that you'll notice is that I'm using a bunch of doubles. Like, you can call this A if you want to, but then like in the previous example, the middle is going to be A over 2. You're going to get lots of fractions, and so I'm trying to avoid that. And again, my job is to make it convenient. So I can call it whatever I want. And so right now, because I want to avoid fractions, and the midpoint, if you remember, the midpoint formula is to take the x coordinates and divide by 2. And then the y coordinates and divide by 2. So I don't want to have to get fractions when I do that, because I'm going to divide by 2 already. So if I have something that's doubled, when I divide it by 2, it'll go in evenly. And that's why it's convenient for me to use doubles. So what I'm doing here is, instead of calling this A, I'm saying that the distance between A and B is 2A. And that would make the x coordinate 2A, and because it's on the x-axis, the y coordinate would be 0. Then C, point C, same thing. I don't know what this guy is, but I'm going to claim that it's twice B. So the distance from here to here is twice B. And then the y coordinate, so the height here is twice C. And that just makes it convenient. I could have called it A, B, and C, but I'm going to call it 2A, 2B, and 2C. So now, the first thing we have to do in this coordinate proof is to verify the midpoints. Okay, I need midpoints. Why? Because to prove something is parallel, I have to calculate the slope of ST, and I have to calculate the slope of AB. And to calculate the slope, I have to have ordered pairs. I have to have the endpoints. I have to know what the coordinates of S and T are. But I don't know the coordinates of S and T unless I use the midpoint formula. And that's what I'm going to do. So the first thing we're going to do is find the coordinates of S and find the coordinates of T. Okay, so the coordinates of S are the midpoint of A and C. So I have, like, the formula is right here, so I need to take the x coordinates of these 2 points. Well, the x coordinate of A is 0. The x coordinate of C is 2b. Divide by 2. Then I have to do the y coordinates. The y coordinate of A is 0. The y coordinate of C is 2c. Divide by 2. Get this out of the way for a second. So that means that I'm taking 0 plus 2b is just 2b, and then 2b divided by 2 is just b. 0 plus 2c is 2c, 2c divided by 2 is just c, and see how nicely that worked out when you don't have to use fractions. So that's going to be the coordinates of S, and do the same exact thing for T, only with T I'm going to be using points B and C. So the x coordinate of B is 2a, and the x coordinate of C is 2b, so I add those two together, divide by 2. And the y coordinate is going to be 0 plus 2c divided by 2. When I simplify that, I'm going to get 2a. You can't combine a and b like I did in this case. 0 plus 2b is 2b. But I can divide both by 2. 2a divided by 2 is a, and 2b divided by 2 is b. So I just get a plus b. So my x coordinate is a plus b. My y coordinate is going to be 2c divided by 2, which is just c. So now, again, no fractions. So I need S and T. So now I have points. Now what I have to do to prove that it's parallel is to calculate the slope of ST and also the slope of AB. So let's do that next. So I'm going to use the little m for slope, and I'm going to do AB. So I'm going to put a little subscript here so I keep track of them. So this represents the slope of AB, and you remember that with the slope of AB, you take the 2 points. So I have 0, 0. That's point A, and B was 2A, 0. So the formula for slope, if you don't remember, where can I write that for you here? I'm going to be crazy. Is y2 minus y1 over x2 minus x1. That was the slope formula. So I'm going to use that formula, and I'm going to claim that this is x1, y1, x2, y2. So I'm going to get 0 minus y1. So y2 minus y1 is 0 minus 0. And then, and then I'm going to go with my x2 minus x1, so 2a minus 0. And I'm going to get 0 divided by 2a, which is 0. Okay? So that's the slope of AB. The slope is 0. Now, I want to find the slope, and I'll do that in a different color so we're not confused here. Now I want to find the slope of ST. So again, I'm going to put my little symbol here, ST. So I'm going to find the slope of ST. And that's going to be using point S and point T. And again, we're going to call this x1, y1, x2, y2. And so when I plug it into the formula, I'm going to get y2, which is C, minus y1, which is also C, all over x2, which is a plus b, minus x1, which is b. So on the bottom, you're going to get c minus c, which is 0, a plus b minus b, so that the b's are going to cancel, and you're going to get a, but it doesn't really matter because 0 divided by a is still 0. So what we're seeing here is that the slope of AB was 0, and the slope of ST is 0, and since they both have the same slope, you have proved that they are in fact parallel, and all we had to do was use algebra. We didn't have to do any of the statements and reasons. And that's how you do a proof. So Now we want you to do it-yourself number 3 to prove this. And I went ahead and already told you what the given was. There wasn't really that much given. They just given the 2 triangles and what they want you to prove. And I've even kind of helped you out with the diagram and labeling the points. So now you have to just do the algebra portion. Hopefully that will be okay for you. If not, I can help you when you come back to class. And then our last one is a coordinate proof to prove that triangle MPB is scalene. To prove that something is scalene, then that means that all the sides of the triangle are different. None of them are the same. And so to do that, we're going to need the distance formula. So I'm going to go ahead and put it up here in case you have forgotten it. The distance formula is the difference in the x coordinates squared plus the difference in the y coordinates squared. Okay? So basically what we need to do in this coordinate proof is really simple. We basically define the distance formula for all 3 parts and then determine that they're not the same. So I'm going to get my calculator because decimals and me just don't always get along. So we're going to find, this is MBP, so we need to find the distance of MB. We need to find the distance of BP, and we also need the distance of MP. Okay, we need these 3 distances, and then we need to make sure that none of them are the same, because if they were the same, then it might be isosceles or equilateral. So remember that we already have the x coordinates and everything labeled here. So I'm going to start with MB, which is I'm going to use these x coordinates. So I've got 33.37 minus 25.8 squared. And then I've got, stay consistent. If I go 33 minus 25, I need to go 64.68. Minus 80.27. I'm going to leave the rest to my calculator, so I'm going to go 33.37 minus 25.8, which is 7.57. And then we're going to square that. Okay, so then this guy's going to be 64.68 minus 80.27, and I get negative 15.59, but I'm going to square that as well and add them together. So right now I'm going to go 7.57 squared plus negative 15.59 squared is 300.353, and then we want the square root of that. So I get approximately 17.33. Okay? So MB is approximately 17.33. Now we do the exact same thing with BP. So with BP, we're going to use these 2 points. So here we go again. And what I'm going to do this time is I'm going to go ahead and do 33.37 minus 18.48. And that's 14.89 squared. And then the difference in the y coordinates is going to be 64.68 minus 66.12. And that's negative 1.44 squared. Okay, so then I'm going to do 14.89 squared plus negative 1.44 squared. And that gives me a value of 223.78 something. So you square root that. Oops. I turned my calculator off accidentally. And you get approximately 14.959. So far so good. Neither of these are the same. One's 17.3, one's 14.9, almost 15. So hopefully we'll get the same result with the last one. So here we go. Let's do this little guy. It's our last one here. And now we're going to use M and P. So I'm going to go 25.8 and subtract 18.48. And that'll give me 7.32 squared. And then we need 80.27 minus 66.12, and that'll be 14.15 squared. And so now we're going to do 7.32 squared plus 14.15 squared, and that gives me the square root of 253.8049, and the square root of that little guy is actually 15.931. So this guy is 17 roughly. This one is 15 because it's 14.95, so this is roughly 15. And this one's roughly 16 because it's 15.9. So they're all different, and because they're all different lengths, then this triangle is scalene because none of the sides are congruent. And so that's basically how you do that. And so I want you to do what you've done before. Again, I've given you all the coordinates, and we want, in this case, for the triangle to be approximately isosceles, which means that two of the sides are not going to be exactly the same, but they should be pretty darn close. So again, do it with the distance formula a couple times, and then you'll get your answer. Once you've completed that, you will have completed your notes for this lesson. I will see you in class, and thank you for watching.